Hello guys, welcome to Science, and today we're going to be learning about convection currents and winds. So let's get started. So first of all, let's talk about the sun. The sun hits the earth unevenly. Yes, I want you to think about the earth and I want you to think about the tilt of the earth. So if you think about the tilt of the earth, you will understand that the sun is actually directly striking the equator more than it does to the rest of the planet. So the equator is going to get the most direct sunlight, which means the area of the equator is going to be a little warmer than the rest of the planet or the poles. If you think about it, the further away you are from the equator, the colder it usually gets, okay? So this uneven heating causes what we call a difference in density. So don't forget, basically what it means when something is more dense, it's going to tend to sink. When something is less dense, it's going to tend to rise. So air over the equator, because it's being actually heated more, is hotter and less dense, therefore it's going to rise. Air over the poles is cooler because it's receiving less direct sunlight and therefore is less dense and it's going to sink. So the density in differences or this difference in density causes what we call convection currents, which basically means air that is warmer is actually moving away from the equator and toward the poles. The opposite happens on the poles because the air is more dense and cooler, is going to move away from the poles and closer to the equator. So basically, we're going to talk about what we call a low pressure system and a high pressure system. The rising air at the equator, yes, it's rising. Don't forget that it's moving away from the equator, will create a low pressure system. The reason for that is because the air is not pressing down on the surface of the earth. So think about it. This air is less dense, is rising up, therefore is not pressing down on the surface of the earth. The opposite applies to a high pressure system because if you think about it, the sinking air from the poles, because it's more dense, is going to basically apply pressure down on the surface of the earth because it's sinking. So a low pressure system is going to be rising, a high pressure system is going to be sinking. Don't be deceived by the colors. A low pressure system does not really mean cold. A high pressure system does not mean hot. So wind is created when air moves from areas of high pressure systems, which we're gonna find basically on the poles, and then this moves basically closer to the equator. So winds travel over a large distance of the earth, and we call these global winds. So again, just to fill in any gaps, high pressure systems, they're gonna move from the poles to areas of low pressure systems, which we're gonna find closer to the equator. Okay? So now, something that you need to remember about this unit is what we call the Coriolis effect. So basically, when it comes to the Coriolis effect, it's just winds basically travel toward the equator and they move on a spiral motion. Winds do not move on a straight line. Again, winds are going to move on what we call the spiral motion. The reason why winds actually move like that is because we have Earth spinning. Don't forget about that. Earth is actually moving on its axis. And therefore, winds are going to basically move. Don't forget, Earth rotates from west to east, and this is why hurricanes and typhoons spin, is therefore because of the movement of the Earth. So now, uh, let's talk about low pressure systems. So when you think about a low pressure system, the thing I need you to remember is this: low pressure systems, low, low, lousy, lousy, and loud. So again, low pressure system, low, low, lousy, lousy, and loud, loud. The reason for that is because low pressure systems are going to create what we call stormy conditions and most likely rain. Uh, the reason for that is because the warm air is rising and therefore is going to create clouds. And don't forget, clouds create rain, aka precipitation. The equator actually has a low pressure system because don't forget, it's being heated more than the rest of the planet. Therefore, that's why we have a lot of rain when it comes to the equator, and that's the reason why we have a lot of the rainforests located there. So hurricanes form over a low pressure system, which makes sense, right? Because hurricanes usually form around the equator. So as the air rises above the Atlantic Ocean, the ocean is heated. Don't forget that. So there is water. Water is being heated. Hot water is going to be driving force for hurricanes. So water evaporates into the air, causing the air to be even less dense. Therefore, this air is going to rise quickly and is going to create huge clouds and powerful storms. Hurricanes usually last, when you actually think about hurricanes, hurricanes will last until they hit dry land. So when hurricanes are over warm waters, they get stronger. So basically, the driving force for hurricanes again is going to be warm water over the ocean. Once they hit land, they usually get weakened. So now let's talk about a high pressure system. So when you think about a high pressure system, what I need you to think is about high, high, happy, happy. When you're happy, you expect clear skies and sunshine. So basically, a high pressure system is going to create areas of clear and sunny weather. This is because the cooler, denser air, it's going to sink. And if the air is sinking, this is not going to create clouds, which means, well, no clouds, no rain, right? So also think about high pressure systems like this. Again, high, high, happy, happy, clear skies and sunshine. But think about around the months of December or around winter. We can get clear skies. It does not necessarily mean it's going to be warm. So a high pressure system just means clear skies and sunny. It does not necessarily means warm. So now, let's talk about heat capacity. If you think about water and land, water has a great capacity than land when it comes to retain heat. Yes. So if you think about your swimming pool, right? If you think about your swimming pool around summer, the water of your pool takes a little bit to warm up because water is going to hold on to that temperature longer. So it takes a lot more energy and time to heat up water. That's the reason why your pool is cold for the few weeks of the summer even though it's hot outside, because water takes more energy basically to get hot. The same applies basically when it comes to actually giving off that heat. Water is going to hold on to that temperature longer. So land, on the other hand, is going to be faster to warm up, faster to cool down. So just think about that as we go through this unit. So again, air is not here directly by sunlight, right? So instead, sunlight hits either the land or the water. So when you think about sunlight, right? Sunlight is either directly heating up the land or the water. The water or the land then radiate heat. So basically, they're just giving off heat. That's all it means. So whatever the temperature of the land or the water is, that will be what the temperature of the air is going to be. So again, what truly is warming up the air around us is the temperature of the surface of the water or the land. So let's talk about two different types of breezes. We're going to learn about sea breezes and land breezes. So when you think about a sea breeze, this is the first thing I need you to think. When you think about a sea breeze, all that it means is just a breeze coming from the sea or the ocean, right? So think about it. When you go to the beach and it's a nice sunny day, the wind during the day, and this applies basically at the day. Sea breezes happen during the day, which means the wind is coming from the ocean or the sea to the land. This happens because during the day the land is going to heat up faster than the water, and therefore the air above the land is going to rise, right? And as this air from the land is rising, now the cooler air from the ocean is going to take over. Uh, the air above the water will move from the high pressure to the low pressure system, and therefore you're going to feel that breeze that is coming from the ocean toward the land. The opposite applies when it comes at night. At night, you're going to have what you call land breezes. So when you think about a land breeze, it's basically the breeze now is going from the land into the ocean. And if you have been to basically like any of the beaches around the world, you realize that the wind really blows back into the ocean at night. The reason for that is because the land is going to lose heat very quickly. Don't forget, land does not hold down to heat as for a long time like water does. So during the night, the land is going to cool down. Therefore, this air is going to sink, and now the warm air is going to be closer to the water, which means now the opposite happens. The breeze is going to go from the land into the water, and that's why you feel the wind blowing toward the ocean at night. So let's talk about basically just jet streams. And basically, jet streams are going to be just like basically bands of strong, predominantly westerly air. So when you think about our planet, right, we think about wind and we think about the spin of the earth. We also think about density and things like that. That's basically what creates jet streams, and we're actually going to talk a little bit more as we go through the unit, okay? But don't forget, winds around the planet move extremely fast, like hundreds of miles per hour, and these winds help to push the weather. Literally, like our winds are shaping our weather, okay? So at this point, you can just stop the video and don't forget to complete the Google form that goes along with it. You got this, guys.